morning, students. Today we will start with the fourth chapter of chemistry, that is carbon and its compound. We have already covered or completed three chapters. First, chemical reaction and equation. Number second, acid, base and salt. And number third, metals and non-metals. In metals and non-metals, I have explained you about ionic bond. And there I have told you that the bond which is formed by transfer of electrons from metal to non-metal is called an ionic bond. Or in other words, we can say that the force of attraction present between cation and an ion is called ionic bond, and the compound which contains ionic bond are called ionic compound. Whenever involvement of metal and non-metal is there in a compound or in a molecule, the bond is always ionic in nature. What if the molecule contains or the compound contains non-metals? Non-metals have electron gaining tendency. So how formation of molecule will be there? How combination will take place between the non-metallic atoms so that we can get a molecule? So its answer is very simple, by the help of covalent bond. Whenever non-metals are involved in a molecule, then transfer of electron never takes place. Losing and gaining of electron is not possible. In that case, sharing of electron between the non-metallic atoms is there. So the definition of covalent bond, the bond which are formed by sharing of electron, it can be one or more than one electron, is called covalent bond, and the compound which contains covalent bond are called covalent compound. Remember, hydrogen is having duplet completion tendency. Duplet completion tendency means hydrogen wants to have 2 electrons in its valence shell, because first energy level in hydrogen behaves as a valence shell, and according to Bohr-Bury scheme, first energy level can accommodate maximum of 2 electrons, while the other non-metals like fluorine, chlorine, bromine, iodine, nitrogen, carbon, oxygen, phosphorus, sulfur are having octet completion tendency. Means they want to have 8 electrons in their valence shell, because having 8 electrons in the valence shell provides stability to the atom. That's why they are going for bond formation. All the noble gases are stable, because except helium, all the noble gases have 8 electrons in their valence shell. Noble gases are inert in nature. They are not involved in bond formation with any other elements by gaining or losing or by sharing, because they have 8 electrons in their valence shell. They are stable in nature. Elements are losing or gaining electrons, or they are sharing electrons, so that they can acquire a stable electronic configuration in their valence shell. And a stable electronic configuration can be acquired either by losing and gaining, or it can be acquired by sharing of electrons. Gaining and losing takes place when metals and non-metals are there, and sharing of electrons takes place when non-metals are there. So let us take an example of H2 molecule. H2 is a covalent compound because bond present is covalent bond. So here hydrogen is having one electron, its first hydrogen. Second hydrogen is also having one electron. So both the hydrogen atom will contribute one electron for sharing. And after sharing, this hydrogen will complete its duplet. 1 and 2 electrons for hydrogen. This hydrogen, by sharing or by contributing one electron, will complete its duplet 1 and 2. So here duplet completion for hydrogen, because each atom is contributing one electron for the bond formation. So there will be a formation of single bond between hydrogen atom. So it is called single bond, or we can say single covalent bond. Then we have example of chlorine. Chlorine is having atomic number 17. So its electronic configuration can be written as 2, 8, 7. Third energy level forms valence shell in chlorine, and in the valence shell we are having 7 electrons. For completion of the octet, chlorine requires only 1 electron. Because it is requiring only 1 electron, so it will contribute only 1 electron for sharing. So let us talk about Cl2 molecule. Here the electron which is involved in bond formation, or it will be shared with other chlorine atom. So electron first, second, third, 4, 5, 6, 7. For first chlorine, Cl, electron which will be involved in sharing or for bond formation. 1, 2, 3, 4, 5, 6 and 7. Each chlorine atom is contributing 1 electron for sharing. So after sharing, they have 1 electron with the 1 electron of other chlorine atom. Both the chlorine atom will complete their octet. Just count. Sharing electron, sharing electron. These electrons are common for both the chlorine atoms. So electrons 1, 2, 3, 4, 5, 6, 7 and 8. 8 electrons for chlorine. Other chlorine 1, 2, 3, 4, 5, 6, 7 and 8. 8 electrons for chlorine. So for both chlorine atom, octet is complete. So Cl is not stable, but Cl2 is stable. Reason? Because in chlorine atom, octet of chlorine is not complete. But in Cl2 molecule, octet of both the chlorine atom is complete. That's why Cl2 is stable. Again, we will be having single bond or single covalent bond between the chlorine atoms in chlorine molecule. Now, let us talk about dioxygen or oxygen molecule. Oxygen, its atomic number is 8. So its electronic configuration can be written as 2, 6. Second shell forms the valence shell, and in the valence shell we are having 6 electrons. Now, for the completion of the octet, oxygen requires 2 electrons. Because it is requiring 2 electrons, so it will share or it will contribute 2 electrons. Because it is deficient of only 2. So both the oxygen atom will contribute 2 electrons for sharing. Electron contributed by first oxygen atom for sharing. 2 electrons by second oxygen atom contributed for sharing. Total electrons in oxygen valence shell 1, 2, 3, 4, 5 and 6. Other 1, 2, 3, 4, 5 and 6. Now these electrons are common to both oxygen atom because it is involved in sharing. Now if we count the shared electron with the remaining electron, it will be octet completion for both oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. Octet for first oxygen atom. Now for second, 1, 2, 3, 4, 5, 6, 7, 8. Octet for second oxygen is also complete. So each oxygen atom will contribute 2 electrons for sharing, and by contributing 2 electrons, each oxygen atom will complete their octet, because each oxygen atom is contributing 2 electrons. So there will be formation of double bond between the oxygen atom, first bond and second bond. So here is the double bond present between the oxygen atom. It is also called double covalent bond. And at last, let us talk about dinitrogen or nitrogen molecule. Nitrogen, its atomic number is 7. Its electronic configuration can be written as 2, 5. There are 5 electrons in the valence shell of nitrogen. Now, for the octet completion, nitrogen requires 3 more electrons. Because it is requiring 3 more electrons, so nitrogen will contribute 3 electrons for sharing. So each nitrogen atom in nitrogen molecule will contribute 3 electrons for sharing. So here 3 electrons from first nitrogen atom which are involved in bond formation or which are involved in sharing, 3 electrons from other nitrogen atom which are involved in sharing. Now these electrons are common to both nitrogen atom. Now count the number of electrons for both nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Octet of first nitrogen atom is complete. 1, 2, 3, 4, 5, 6, 7, 8. Octet of second nitrogen atom is complete. Because 3 electrons from each atoms are contributed, so there will be formation of triple bond between the nitrogen atom. This bond is also called triple bond, or we can say it is triple covalent bond. Remember, we can have single bond between the 2 atoms, we can have double bond between the 2 atoms, we can have triple bond between the 2 atoms, but 4 bonds between the 2 atoms is energetically not possible. 4 covalent bonds between the two atoms are never formed. It's not possible. It's not permissible. So that's all for today in covalent bond. Thank you and have a nice day.